Hi, we are engineering brothers, and this is going to be our first problem regarding our stability over here. And for our stability consideration, the characteristic equation is very important over here, as we are solely focusing of our location of our poles, or whether that the poles are considered for which state S plane over there. That will be the much needed consideration over here. So the characteristic equation for our given system is quite important for us to understand the system stability, or whether the system is stable or not, or what seems to be the condition for that stable characteristic or stable systems over there that should be defined over there. But at first we should define the characteristic equation over here. Now in this given problem, we are having our closed loop system. According to our formulation, we do know that the closed loop control system do have the ratio as Cs by Rs, or do have the transfer function that is Cs by Rs, which is Gs divided by our 1 plus of GSHS, and that will be equal to, and that is been given as just like this one, which is 2s square plus 6s plus 5 divided by s plus 1 squared and s plus 2. And according to our analogy, we do know that how do you define the characteristic equation over here. According to our formulation, we do know that the denominator of our ratio, that will be equal to 0. That is quite naturally 1 plus GSHS, that will be equal to 0. Now in this case, or in this given consideration, this the multiplication of this s plus 1 squared multiplied by s plus 2, that will be equal to 0. That will be our given characteristic equation over here, which is s plus 1 squared s plus 2, that will be equal to 0, because you can see that in our denominator portion that is been considered as this one, that will be equal to this one, that will be equal to 0. Now this is going to be our much needed characteristic equation over here, and that is going to be our first step in this case to consider over here. And why do we consider the characteristic equation? Because as per our analogy, we do know that the location of our poles in our S plane is the much important consideration over here. And according to our transfer function analogy, we do know that the characteristic of our system is solely dependent on our characteristic consideration over there, or the characteristic equation over there, and the stability of our system, and whether the system do have the poles or zeros over there, that will be considered by a characteristic equation over here. So this is the consideration. Now in our given problem, we are having the closed loop system transfer function that has been considered as this one, and according to our closed loop analogy, the formulation will be Gs divided by 1 plus of Gs HS, and we have already established this formulation in our previous videos over there. If you have missed our previous videos, please do follow our previous videos. And that will be equal to 0, and the denominator portion, that will be equal to 0. Now this is going to be our much needed consideration for our transfer function over here, for our characteristic equation over, and this is a formulation for our characteristic equation, that will be equal to this one. Now this is our final answer over here, and this is our characteristic equation in this given problem over here. I hope you have totally understood up to this one. If you still have any doubts, please let us know in the comment section for better understanding. Do like, do share our videos, and keep following our channel. Just wait for my next upcoming problems or any conceptual descriptions over there. Stay tuned with our classes. Do follow our videos. That's it. Thank you and goodbye.
If you like my video, so what are you waiting for? Please do subscribe my channel, hit the bell icon for more updates, and stay tuned to the channel. Thank you and goodbye.